All right, now it's gone. What is our last one here on our warm-up? It's a line. This one's the one where students make a ton of mistakes because there's 3 points. What's one way that I could label this line? Line AF, sure. So I have line AF. Or I could flip those and call it line FA. What's another way I could label that line? BF, sure. What did you say, Jaden?
FB.
FB. Or you could go AB or BA. Any of those would be correct answers. I don't need all of them. Certainly, I only want one of them if you're taking a checkout or a quiz. Okay, but any of those are fine. What would be incorrect is if I wrote line AFB. That's a no, no points there. Okay, when I label a line, I only use 2 points. I never use more than 2 points. Okay. Then on the bottom half, it asks us to draw. Oh, this printed funny, just because it was the program it's in. So I'll have to help us with that.
That was weird.
Yeah, that's my fault. So plane M. Plane M.
Did it.
If it's labeling with just the letter and not with points, then it's not going to be in the middle. It's going to be in one of the corners. It doesn't matter which one, but M would be somewhere here. It wouldn't be like in the middle. If it was plain XYZ, like here, then I can put those points anywhere.
Yeah.
What is happening up there?
Of where?
Okay. I'm not sure what AB was supposed to be. Let's call it a line. So if I have line AB, then draw a line. So here we are drawing. We're not just labeling, we're drawing line AB. Make sure we have clearly identified points when we're drawing. What is DC asking for? A line segment, which means it's just going point to point, no arrows there. So from D to C, a line segment. Let's say that HG was supposed to be array.
Oh, well.
And if I have array, I could go crazy and go backwards. But I know that the end point is at H. And the arrow side should be where the point G is. Okay, so order matters with our array, end point to arrow.
Correct.
Plane XYZ, this is also just that little, almost looks like a parallelogram when we draw our planes. But instead of giving us a little notation in the corner, XYZ means there's a point X on it, there's a point Y on it, and there's a point Z on it. Last diagram asks you to draw collinear points, K, M, and N. What does collinear mean? On the same line. So it doesn't matter where they are as long as K, M, I don't know why I drew that one up above. As long as K, M, and N are on the same line, they're sharing a line. Collinear points.
Oh, hold on.
Yeah.
Mind if I ask a question?
Yeah, Jaden, what?
Oh, if they're on the same line, they're collinear,
Yeah.
right? Well, what about the other one, the AFB? What makes that different?
It doesn't, they're also collinear.
Oh, then why do you say it was a line?
But they're also collinear, but here I'm drawing the line, so I want to show all my points. Here I'm labeling a line that has 1 or 2 points, and so when I label, I only use 2.
Oh, okay, sorry.
Okay? All right, so now if you could find your notes, notes number 2, it says more geometric terms. I know you were hoping we could do more vocab today. Notes number 2, more geometric terms. All right, so first thing we're talking about is when two lines intersect. So I'm actually going to go over to the visual first. So all we're saying, well, what happens when one line, let's call it line L, intersects with another line, let's call that line M. Tell me, where do they intersect? Do they intersect at a point, at a line, at a plane? Where are they intersecting at? One point. They're only going to hit at one point. Okay, we'll call that point P. So I'm not really doing a definition here. I'm saying what happens? Two lines intersect. Two lines intersect at a point. Okay, the intersection of two lines would be at a point. You're going to test your drawing skills on the next couple. Intersection of two planes. So I just want to remind you, planes go on and on. So even though we only draw a rectangle, they're still extending in all directions. So I'm going to draw an intersection of two planes as best I can, and I can't that well. So let's see. Here's a plane. We'll call it plane N. And then here's another plane. I have it going this way. Oh boy, I went a little big. And, oh, it's bad. This is the worst one I've ever drawn. Look at that. It's supposed to be a rectangle. Okay, but it's, it's bad. It's going through that plane. And so where they meet would be a what? Would be a line, and it's not a segment. It continues on because remember, just like the coordinate plane can, that's a bad, here, I'll show you, my drawing from last year was so much better. That's kind of what it's supposed to look like. Okay, so I have this one plane and this other plane, and again, they're extending beyond what that rectangle is actually drawn as, so they hit, and it's a line running along them. Okay. So the intersection of two planes is a line. Okay, again, extends infinitely. This one I can do better. An intersection of a line and a plane. There's actually two cases here. So first scenario. What if somebody just fell through the ceiling, right? Okay, first scenario is we have a plane. And we have a line that's not on that plane. So that line's not on that plane. It's going from above the plane, hitting the plane, and then coming out the other side. Okay, but it's not lying on the plane. It's just hitting at one point, intersecting at a point. So this would be a line not on the plane, and it intersects at a point. Okay, that's one case. The line's not on the plane and it's intersecting at a point. But I could have a plane and I could have a line that's lying on the plane. Okay, so like when I have the coordinate plane and I draw a y equals mx plus b line on top of it. It's a line on the plane. It's lying on the plane. And when that's the case, and it intersects at the line, okay? Any point on this line is also a point on the plane, so they're intersecting all of these points along this line. Okay, two different cases that could happen. So in terms of filling in over here, the intersection of a line and a plane could be a point or a line. Okay, and you should look at your visual to know which situation do you have is going to determine if it's intersecting at a point or at a line.
Oh, Miss Sawyer,
Yeah?
could you, what's the term for it?
What's the what?
The term, sorry, I didn't see.
The term. Oh, I'm on intersection of a line and a plane.
All right.
I don't know why my audio is so quiet on that. Actually, maybe I do. Okay, opposite rays. So these are a little more straightforward. Opposite rays, so we know our ray goes from a point to an arrow. So I'll call this ray X, Y. There's a ray. An opposite ray just means going in the other direction. So everybody else, so I could go this way. Call that ray XZ. Opposite rays. Any two rays are gonna hit at a what? They met at a point, a vertex. Yeah, it's called the vertex point. That's what creates an angle. Okay. So for any of our rays, if I have two rays, they're going to intersect at a point. Oops, at a point, and yeah, that's called the vertex point. What does the word congruent mean? Does anyone know? Anyone heard that word before? Stella?
I have, but I don't remember.
The what? No? Did someone shout it out here? Congruent. Congruent means equal parts or equal to. Now, you're like, but doesn't the equal sign mean equal to? They're very similar. Congruent is like equal in measure. Yeah, and it has a different notation. So it really feels like the equal sign, and we kind of use it like the equal sign over and over again in geometry. But we're saying of equal measure. Okay, so like congruent segments that we're going to look at in a minute. So the notation, not going to give us a visual quite yet, for congruent is the equal sign, and yeah, it's got this little squiggly guy on top. Okay, that's our congruent symbol, which means of equal measure. Which means that if I have congruent segments, our next term, congruent segments means segments of equal length. I'm doing my best to show two segments that are the same length. They don't have to be going the same way either. The way that we mark congruency is with what's called tick marks. So I can say these are congruent segments, and I can see that they're congruent because they're marked with the same tick mark. I could have in the same diagram, I could even just add on to here, shorter segments here, go E and F, and I would use a different set of tick marks to show, okay, this length and this length, they're the same measurement, and this length and this length are the same measurement. We use those tick marks to show which ones match up and are the same. And I could write that, say, in a proof soon enough. I could say things like AB from A to B is congruent to CD. That AB is congruent to CD, that they're the same length. And I can say that BE is congruent to DF. Okay, that's how I write that in a proof. So we see this congruency for things like a midpoint. What do you think a midpoint is? We just did it in our quiz algebraically. We found the midpoint, and the midpoint was the middle of the line. Yeah, so middle of our segment. So the midpoint is the point. Let's zoom that in for this case. The point that divides a segment into two equal segments. That's our definition. Give you a chance to write that down. Point that divides a segment into two equal segments. So drawing a visual of that, we have a segment, and in the middle, so I'm going to call this L, M, N, label my points, and I can mark with tick marks that LM is equal in length to MN, that it cut it into two equal parts because M is the midpoint. Okay. And so again, notation, I can say LM is congruent to MN. I guess I should be using segment notation. Okay, add our little segment above. Really similar to my midpoint is a bisector. What does bi mean? Like if I say bicycle versus tricycle, two. So it's again, right, cutting in two. Be different, so very similar to midpoint. If I trisect something, then I'm cutting it into threes, yeah. So bisector means I'm going to cut into two equal parts. Sounds super similar to midpoint, right? But we're gonna look at the visual. A bisector is a little different. When something's getting bisected, it's more than just there's a point that's in the middle. If I had a segment, and note that a line goes on infinitely, so we can't like cut a line in half, but we can cut a segment in half because a segment has a set distance, okay? So if I had a segment X, Y, the segment could be bisected by a line so that there's something going through it, actually cutting the segment in half. That line's going through the middle and cutting it into 2 equal parts. Or a segment could be cut by a ray, or a segment could be cut by another segment. Could have a segment over here. Again, we could call it XY, and it could be cut by another segment. And notice the way that I drew that. This doesn't look like it's bisected. That's not being cut into equal parts. But this segment is cutting this one into 2 equal parts. Okay, this is the bisector of this. Okay, so it's kind of like midpoint, but a little bit different. We use bisect more with angles than we do with segments. Okay. Now let's practice this a little bit. So when you're ready, look at the next page in that diagram. Okay, so this is where it gets a little, you gotta really focus on what it's asking you for. So we got this lovely diagram here. Lots going on. So some things I see happening, I see this line is being intersected by this line. This line is also being intersected over here. This plane, K, is being intersected by this plane, I think, L. Okay, and it's intersecting here. Okay, so whole lots of things going on. I don't have a highlighter. We'll do our best. So first question that it asks, we should be able to do this one, is it says gives 5 other ways that we could name line AB. So here is line AB. Okay, it's going across the middle here. What's one other way that I could name line AB? Yeah. AG. I could call it AG. And then along with that, I could call it, yeah. So I have AG, line notation on top, or GA, what? GB. Yeah. Or along with that, if I can call it GB, BG. Okay, that's 4. What's the 5th? Yeah, you could if there was a little letter out here, but I don't have a little letter. See if I can hear anyone on here. What about our Zoom participants? Can you spot the last way to name that line? Yeah.
Wait a minute.
Flip the AB that it started with and call it BA. Okay. Many possible responses to this next one. So there's not one right or wrong answer. Well, if there are wrong answers, there's not just one right answer. So it says, name a set of 3 collinear points. Who thinks they have one? If you're on Zoom, you could type into the chat box or you could yell out, but for some reason my volume's not that high. Gemma, what do you think?
F, B, E.
F, B, and E. F, B, and E. Yep, those are collinear. But there's other correct responses. What else? D, G, C. Yeah, here, D, G, C. Another correct response. Any of these are fine. I'll put F point B. So look at how I'm writing that. I just wrote the line Gemma gave us, but I put the points in front of the letters. I can't just write FBE. It has to be point F. Okay, the labeling, it's really specific in Geo. Point F, point B, point E. Or we said, I'm gonna run out of space on this one. Point D, G, and C. Or, give me another one. N, G, N. Yeah. N, G, and there's even, I think, we could also say A, G, B. Okay, so there's more in there. Any of those lines that have 3 points I can use. I don't think there's a line on there I can't use. They all have 3 points. Okay, this one's a little tricky. List all rays that with endpoint G. So I'm gonna zoom in for a minute. So here's endpoint G. G is right here. How many rays are coming off of G, do you think? 6. There are 6 rays shooting off of G. So it goes GC, GN, GB, GD, GM, GA. Okay, that's all of the rays that start with endpoint G. So there's 6 of these. Labeling correctly, so GA, ray GA goes from G through A. Ray GB, from G through B. GN, GM, GD, GC. And there's my 6 rays. That's all of the rays that start with endpoint G. Four pairs of opposite rays. So rays that one endpoint goes endpoint this way and the other one goes endpoint that way. Well, we have quite a few up here. GA would be opposite with, well, so what they're asking for here is like directly opposite because, yeah, so GA and GB are going opposite directions. I probably should have done my visual better on the first page. So that's one set. Oops. GA and GB. And then what else? GN with, yeah. GN and GM, so I'll show you that. GN and GM and GC with GD. That's 3 sets of opposite rays, and it asks for 4. Right here. You have BE is opposite BF. So our last set, BE and BF. This one's easy. What's another name for segment CG? I don't even need to look at the diagram. If it's a segment, G to C, I could also call it G. Did I say G to C and when I said it out loud? From C to G, I could also flip it and write it from G to C. Segment GC. Let me point that out though. We were just talking about GC as a ray. GC is a ray here. But I can also say from G to C is a segment. It's a part of the ray, okay, that they're using GC here. We also can use GC as a ray. We can also use this whole line. So there's like pieces within each of these diagrams. Are A, G, and N collinear? So let's look at that. A, G, and N. No. So A and G are collinear. G and N are collinear here, but all three of them are not on the same line. Okay, so that's no. A, G, and N collinear, that's a no. Are points A, G, and N coplanar? Yeah, so coplanar means on the same plane. So they're not all on the same line, but they are all on this plane K. A, G, and N all sit on this plane. Now G and N are also on this shaded plane, okay, but they're on both. They're on the intersection of the two. Yeah.
If there are points on the sides of the planes, are they always?
They're on this shaded one.
Oh.
Yeah. So like if it had said A, G, and D, no, they're not coplanar because D is not on this plane. Okay. So like D and C and J are on their own plane. They don't overlap with this stuff that's happening on this white one. But there are some points that are on both. So N, G, and M are on both planes because it's where they meet up. So they are coplanar, yes. Name the intersection of AB and MN. So going back up. AB I've already highlighted. MN is here. Where do those two lines intersect? G. And remember, so like when you're doing this homework, on that first page where we went through this, we know that two lines intersect at a point. So that's what that is there to help you with, is I know that my answer should be a point. Like it shouldn't be a segment or line or array. The answer to an intersection of two lines should be a point. The answer to the intersection of a plane and a plane, again, if I use my resource of my notes here, intersection of two planes, I know that two planes intersect at a line. So I know my answer should be a line. So it says, where do the two planes intersect? Where are they intersecting? N. I could call this any of the variations of this line. There's 3 points on this line. So I could call it NM, I could call it line MN, NG, GN, GM, MG. It's a line, so it doesn't matter, because I know even if I use point G, still extending past that, because it's a line. Okay, so any of two of these 3 points I could have grabbed. Probably most people would just go from M to N though. Okay. Again, on our vocab on the first page, we talked about the intersection of a line and a plane, and that's the one where it depends. The line can be on the plane, or the line could not be on the plane. So let's look. So it says plane ABH. First thing I'm going to ask you, where's H? Oh, I see it. Which plane is ABH? Is it K or L? K, yeah. A, B, and H is this white plane, not the shaded plane. A, B, and H, that's plane K. So it's saying, where does this plane and line CD, which is here, intersect? Is CD on that plane? No. So CD is only hitting that plane at point G. Yeah. Good. Okay. So